Okay, so this video pertains to section 1.2 in your textbook from the pre-calculus. And it's a section about functions. I'm going to split this down into two because there's a lot of stuff covered in here. So this first section is just about what is a function and how to identify if something's a function or if it's not a function. And there will be another video that covers other topics that are in this section. So first of all, what is a function? Your book defines a function as a correspondence from a first set called the domain to a second set called the range, such that each element in the domain corresponds to exactly one element in the range. So we're going to try and flesh out what that means. Graphically, we usually have something that looks like this. This is classic similar diagrams in your textbook. But these values here are our domain. And usually when we talk about functions, our domain is always our x value. And they're mapped to values in our range, our y value. And you can see 1 is mapped to D, 2 is mapped to C, 3 is mapped to C. This is a function because each one of these elements in our x value is mapped to a single element in our range. So, and it's absolutely okay for two elements in our domain to be mapped to the same number in our range, just not for an element in our domain to be mapped to two elements in our range. So if 2 was also mapped to B, then that is no longer a function because 2 would be mapped to two values in our range, not exactly one. Okay, so there's a couple ways that you're going to be asked to evaluate if something is a function or is not a function. So the first way is usually they'll give you a set of numbers, a set of data, of points. So in this first set of points, we have -2 is mapped to 4, -1 is 1, 0 to 0, 1 to 1, 2 to 4. So we look at this, and we don't have any repeats of our x values. So each x value is mapped to only one y value. Now, if you'll notice here that 1 is mapped to 1, -1 is mapped to 1, and 1 is mapped to 1. So the two x values can map to one y value. This is still a function. It's only when we have two values of y mapped to one value of x. And if you see here, we have 1, 3, 2, 4, 2, -4, 6, 1. This 2 mapped to 4 and 2 mapped to -4, that is one x value mapped to two y values, or one domain element mapped to two range elements. So this is not a function. Okay, so we have sets of points. The other way that we can evaluate if something is a function or not is if we have equations. Now with these equations, the best way to approach this is to solve for y. And then you can evaluate if one value of x gives you a single value of y or two values of y. So in this case here, we have x squared plus y squared equals 25. We're going to solve for y. So we're going to subtract x squared from both sides of this equation. So we get y squared is equal to 25 minus x squared. Okay. Now to solve this, we have to take the square root. But remember, when you're solving equations, when you do this, you take the square root to solve an equation. You always have to have the plus and the minus value here. So when we do this, we get y is equal to plus or minus the square root of 25 minus x squared. So now for each x value that we put in here, we're going to have a positive value and a negative value. So we're going to have two y values. So because of that, this is not a function. If we look at this one here, we have 3x plus y, where again, we're going to subtract 3x from both sides. We get y is equal to 11 minus 3x, or negative 3x plus 11. And in this case, we see that there's exactly one value of y for every value of x. So it maps a single value of x to a single value of y. So this is a function. Okay. The final way that we can do this is that there's something called the vertical line test. The vertical line test, we're going to have a graph. And what the vertical line test says is we can draw a graph, a vertical line at any point in this graph. As long as it only hits one point on the graph of our function, then it is a function. Okay, so we could, I drew this graph here like about -1, but you could draw it here. You could draw it any place on this, on the graph of this function, and it only hits the graph in one spot. So this is a function. We have another one here. If I draw a vertical line, I hit this graph in 2 spots. So for this given value of x, there's 1, 2 values of y. So it is not a function. Again, here I can draw a vertical line, and I've drawn it here about 6, but you can draw it anywhere where it intersects this graph, and it's going to intersect this graph in 2 places. So this is not a function. Now both of these examples here, you could draw the line any place it's going to hit twice, but that's not necessarily the case. You can, if you have a function, it can, you only need one spot on the graph where it intersects. Okay, so you don't think that you have to have multiple spots. It's like if you can draw a line anywhere and it hits 2 points, then just one spot that it hits 2 points, then it's not a function. And this final one here, again, we can draw a vertical line anywhere, and it's only going to intersect this graph in one spot. If we drew it here, it just intersects at one spot. Okay, so a function is something that maps your domain to your range with a distinct single value for your range associated with each value of your x. So we can look at data points and make sure that we have ordered pairs that have that don't have a repeat in the x value that goes to a different y value. We can have equations. We solve those equations for y and evaluate if there's any way to get two y values for a single x value, or we can do this vertical line test.